think we're ready now to tackle some more or even more complicated examples. So let's draw something crazy here. So let's see, let me draw a chain. And let me draw it like that. And so, like we've done in all of the examples, you want to find the longest chain. We could count from here 1, 2, 3, 4, 5, 6, 7, 8. Or maybe it's 1, 2, 3, 4, 5, 6, 7. No, or maybe it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is our longest chain. Let me make that in green. So our longest chain here is in green. So this this backbone has 10 carbons in it. The prefix for 10 is dec. It is a alkane since it has all single bonds. So we can write decane for the backbone. And then it has a group right here. It has a group right here. And this group consists of 2 carbons attached to the backbone. The prefix for 2 carbons is eth, so this is an ethyl group. The YL is because it's a group attached to the main alkane chain. So we call this ethyl decane. But we have to specify where the ethyl group is attached. And we want to give it as low of a number as possible. So we start counting on the side closest to it. So it's 1, 2, 3, 4, 5. So this is 5 ethyl decane. Now let's complicate this a little bit more. So let me just copy and paste this. Copy and then paste. So I have pasted it there. And let me complicate this molecule a little bit more. Let me add another ethyl group to it. Let me add another ethyl group to it. So let's say we have another ethyl group over there. Now what is this going to be? Well, the longest chain is still going to be that thing in green. So it's still going to be a decane. It's still going to be a decane. But now we have 2 ethyl groups, one on the 5 carbon, 1, 2, 3, 4, 5, and then one on the 6 carbon. And then one on the 6 carbon. So what we write here is, you might be tempted to write 5 ethyl, 6 ethyl decane, which really wouldn't be wrong, but it would just be maybe more letters than you want to write. Instead you write 5, comma 6 diethyl, diethyl decane. The 5, 6 tells us the 2 carbons on the main backbone that the ethyl groups are attached to. And the di says that we have 2 ethanes, or 2 ethyl groups, I should say, not ethane groups. 2 ethyl groups, one over here and one right over here. Now let's make it even more. Let's make it even more complex. Let's take our thing and let's make it even more complex. So let's copy it and let us paste it. Edit, paste, just like that. Let's paste it. Let me make it a little bit lower over here. So the exact same thing we just dealt with, but let's add one more. Let's add one more group to it. Let's say it looks something like this. Let's say on that 5 carbon, let's say on that 6 carbon right there, I have a group that looks something like this. What is this going to be called? And here we probably want to break it down a little bit. We still have the backbone, so it's still going to be a decane. It is still going to be a decane. But let's just do it step by step. So we know that this right here, this is an ethyl group. It's on the 5 carbon, so that is a 5 ethyl. This is another ethyl group on the 6 carbon, so that is a 6 ethyl. Now we have this group over here. So how many carbons are on this group? Well, we have 1, 2, 3 carbons on it. We have 3 carbons on it. So we might want to just call it a propyl group. But notice something. We are attached to the carbon, and then it later branches off into 2. It actually immediately branches off into 2. So we could actually call this either sec-propyl. So this right here, we could either call it sec-propyl, or because it is connected away from the, I guess it's connected directly to the branch. The way a propyl group works, you could connect to it and it immediately branches because you only have 3 carbons. So propyl, just to clarify things, it's sec because we're attached to 2 carbons right there. But sec-propyl isn't what people normally call it. They normally call it isopropyl. Isopropyl. And the iso root comes from anything of the form. So if I have a group that looks like if I have a group that looks like this would be isobutyl because we have 1, 2, 3, 4 carbons, and we are attached right here. So this is where we would attach to the main backbone. If I have a group that looks like this, so let's say I have a group that looks like this would be isopentyl. I have 1, 2, 3, 4, 5 carbons. I'm attached away from the branch. But if we go one step more closer, so we're attached just like this, we're attached to the original group. This is isopropyl, 1, 2, 3 carbons. Let me write isopropyl, isobutyl, isopentyl. Notice what the isos. The isos are like Y's. I guess is the best way of thinking. You're attached to the base of the Y. In this case, you're almost attached to the base of V, but hopefully you get the idea. So the common name for this group would be isopropyl. Or if we wanted to use a systematic naming, we could just start at 1 as being, let me do this in a good color, as the carbon we are attached to. And then we only have 2 carbons right over there. So if we have 2 carbons, we're dealing with an ethyl group. We're dealing with an ethyl group. And then you could say that you have a methyl group attached to the first carbon. So it would be 1 methyl, 1 methyl ethyl. So this could either be called an isopropyl group or a 1 methyl ethyl group. And in either case, and we put that in parentheses, in either case it's attached to the 6 carbon. In either case it's attached to the 6 carbon. So the prefixes are going to be on the 6th carbon on our main, we have a 1 methyl ethyl, methyl ethyl, where the methyl is attached to the first carbon on the methyl chain. On the the methyl is attached to the first carbon on the ethyl chain, or we could call this 6 isopropyl. Isopropyl group attached to the 6th carbon. Now, when we decide how to write it, how do we know? We're going to have to write essentially the ethyl and the isopropyl. We're going to have to write all of that in front of the decane. How do we decide whether to write the eth or the propyl first? Well, here you just do it in alphabetical order. And actually, these little prefixes in front don't matter. So you compare the P to the E. Eth, E comes first in alphabetical order. So this would be 5, 5, 6. Diethyl. So even though D, well, D comes even before E, but you don't even count that prefix. The E is what matters. Diethyl, and then we could say diethyl 6, 6 isopropyl, 6 isopropyl, isopropyl. This is the common name. 6 isopropyl decane. Isopropyl decane. This would be the common name for it. If we wanted to use a systematic name, we would replace the 6 isopropyl with 6 1-methyl ethyl. So let me write that down. So let me just copy this part. So copy and paste right there. And then I can copy and paste this right here. Copy and paste. So it becomes 5,6-diethyl 6,1-methyl ethyl. I know it's very confusing when you see it, but when you break it down, you would be able to draw this from this structure. And then finally, you finish with a decane. So hopefully these examples don't confuse you too much. In the next few videos, we'll do more and more examples. Because I think with the nomenclature on the organic chemistry, the more examples you see, the better. And this is really core, so in the future you don't get confused when people throw out something like 5,6 diethyl 6 1-methyl ethyl decane.